Hello everyone, welcome back to the new video. In this video, we are going to give the functionality of this laser pen. We will add this nice animation. So first thing, let's go to our presentation package and the whiteboard package. And first thing what we need is a state where we can keep the laser pen path. So let's duplicate it and change the name to laser pen path. And now go to the view model. And if we go to the domain package and the model and this drawing tool, right now if I press Ctrl B on this laser pen, right now there is only one place where we are using this laser pen tool, and these first four are just implementation of our DAO. So go to this line. What we are doing right now is scroll up. So here when user will start drawing the path, then first on this start drawing event we are saving the starting offset, and on the continuing drawing we are updating our continuing offset. Let's press Ctrl B. Here we are handling the path creation in the similar way as we are doing with the pen and this highlighter. And in the end of this update continuing offset, we are just updating our current path, and after this continuing drawing event, we are handling the finish drawing event when user will stop drawing the path. So here what we are doing right now, we are just simply taking the current path and inserting that path into our local database. But with laser pen, we are not going to do this. We will not save that current path of that laser pen into the local database, but that current path we will save into the laser pen path state. And from that laser pen path state, we will create an animation. So here on this current path, let's put a when block when this drawn path is drawing tool dot laser pen, and let's here use the else block. And here we need to check the drawing tool of this drawn path. And if we have laser pen, then we just gonna update our state of that laser pen path. And for every other drawing tool, we will insert that path into our database. So now we have the laser pen path in our state, and from that state we are going to create an animation. So go to our whiteboard screen and scroll down to bottom, and here create a new function with the name animated laser path, or just animate laser path. And to this function we will provide the laser pen path, and this can be null. Now let me show you how this animation will work. First see this animation. Suppose if I draw this path, and here this path is continuously shortening from the starting. So how this animation is doing? Suppose if I draw some path like this, and here this is our starting point, and this point is the end point. So what will happen? With every passing moment, we will shorten our path from the start. And if I draw these paths, suppose next moment the path will be this, and then this, and then this, and at the end it will disappear like this. So what we need is the new line segment with every passing moment that will decrease from the start point. So for that we have this path measurer class in our compose, and we are going to use this apply. So we will get the access of this class, and first let's see the documentation of this path measurer by pressing Ctrl B, and here this function is extending this interface. So here we have the documentation of this path measurer. We can see we can get the length of any path and also we can get the segment means a portion of that path by providing these values. And also we have this set path function and this get position and this get tangent, and we are going to use these first three things to get a new line segment. So first thing, we need to provide a path to this path measure so it can get the value of that path with the help of this set path function, and our path will be laser pen path. And here put a null check and get the access of path. And next value we need to provide is this force close to false, and add arguments also. So this force class we are specifying false because our path is not a closed path. And now we need to get the segment, so for that we have the get segment function, and here we need to provide values, this start distance, stop distance, and this destination, and that start with move to will be true by default. So these first two values, here we need to provide the starting point and the end point of the line segment we need to get. Here you should read this start distance as the starting point and this stop distance as the end point. So our endpoint will always be same for all the line segments. So for that we can get the endpoint with the help of this length. So whatever will be the length of that path, that will be the endpoint. Here in this destination we need to provide where we want to save this segment. So for that let's create a new value with the name trimmed path and initialize it here with a blank path, and we are going to save this segment into this trimmed path. And let me put also a comment. Now next thing, we need to provide this starting point, and with every passing moment this starting point needs to be decreased from the start to end. So for that, here let's create a value with the name animation progress, and this value will be animatable, and initially we are going to keep one f value. And for this start point we are going to get with length into 1 minus animation dot value. So initially we are keeping this animation progress to 1 value, and we are subtracting this 1 from 1, so it will give us the result of 0. So if we multiply it with length, so we will get the starting point as the 0, and we need to animate this 1 value to the 0 value. So suppose if after passing 200 millisecond this animation progress value will be zero point 0.8, and by subtracting from 1 it will be zero point 0.2, and then we will multiply it to length, then we will get the point somewhere here. So we need to animate this animation progress value, and for animating this animation progress value we will use this launched effect, and here key we will provide to this laser pen path. So whenever this laser pen path will change from null to some path, then this launched effect code will trigger. So here we just need to use this animation progress value and animate to, and we need to animate this value to 0f, and this animation should take 1 second. So we will provide this with the help of this tween. 1000 millisecond means 1 second. This tween is just the short of between, and let's also wrap this. Only it should happen if our laser pen path is not null. Now in the last we need to use canvas to draw this trimmed path. So here use a canvas with modifier fill max size. Use this laser pen path is not null, then we need to use this draw path function, and here this path will be our trimmed path. So we need to put this trimmed path outside this path measure block so we can access this here also. And the color will be the laser pen path dot stroke color, and style of that laser pen path will always be stroke. Now let's use our laser pen path function in this drawing canvas. After this canvas, let's also use this here. And laser pen path we need to provide, and we can get from the state. Now let's minimize this and run our desktop app. So here is our desktop app. Let's create a new whiteboard and open our laser pen. And if I draw something, and here we have the cool animation. Hey everyone, if you are finding this tutorial helpful, you will love my premium Udemy course where we will build Measuremate, a fitness app using Jetpack Compose. We go in depth on the Firebase authentication, Firestore, and more. Check out the course in the description and take your skills to the next level. See you there. But this laser pen path will only animate on the first try, and if I try to draw subsequently, then there will be no animation. Why this is? Because we need to reset our values to the default ones. So here in our animate laser pen path function, here after when this animation will complete, we need to reset our values to default. First value we need to reset this animation progress to again 1. Here we need to reset this animation progress, and for that we have this function snap to, and we need to go back to the 1f after this animation complete, and this snap to function will set the current value to the target value without any animation. And next thing we need to reset is the current path of that laser pen path. So for that, here let's create one callback on animation complete. And after this, let's call our on path animation complete function. And this function we are using here. So this parameter we need to access in our view model. So for that, go to our whiteboard event and create a new event data object on laser path animation complete, and attach this event here. And this event we are going to manage in our view model. So here this function is giving errors, so let's add it here. And here we just simply need to update our state of that laser pen path again to null. Now we can run our app again and see this. And here we have the desktop app. Open this. Let's first draw some paths. So if I use this laser pen and I need to highlight this part, and here we have a cool animation. And if I change the stroke to different, then again we can get animation of that color. So our laser pen tool functionality is working perfectly fine. Now let's close all this. Now next we are going to do some code reformatting. So first thing what I need to change is here I need to make all these update functions in a single line. Next thing, let's also call these create functions in a single line. So for that, just remove these parentheses. Next thing, let's also simplify the creation of this triangle path. And also this code session I got on my YouTube videos comment. So we are going to incorporate it. First here we are calculating the height. So here just remove this absolute value. So that triangle can go upward and downward in both way. And instead of calculating this half base width, let's calculate the base width. And again, let's remove this absolute and this divided by 2. And in our triangle, the first point will be the starting offset, and the next vertex of that triangle will be simply the end offset. Only we need to calculate the third offset. So let's just delete this part and rename this value to remaining vertex. And this will be our remaining vertex, and we can get the x and y offset from it. And this is how we are going to calculate the triangle path. And also I need to change this circle path function. First let me show you right now what we have. So if I draw the circle, and here we can see we can create an oval and a circle, but if I go on the top side, then rather than creating that circle into that way, it is just creating the circle only downward. So let's also change this by simply removing this absolute value. Now let's run our app again, and this time let's run our Android app. And let's create a new whiteboard and draw some path. And now create this circle. And if I drag downward, then this circle will go downward, and if I drag it to the top, and this circle can go all the side. And this is how our new path creation will look like. And same will go with this triangle. We can also draw our triangle upside down. Let's also see the laser path animation. So this was all for this video. We have successfully added the laser path animation, and in the next video we are going to give the functionality of this eraser tool and also changing the canvas color. I hope you are finding these videos helpful, and as always, if you have any suggestions, feel free to drop down the comment, and thanks for watching.